Good afternoon. Welcome to Infosys technical session. From morning session we discussed some topics. Today also we are discussing this session also we are discussing on arrays and some programs. So how do we there are two types of arrays can be declared. One is compilation type and second one is runtime arrays. Okay, fixed. It is also compilation time also. In the previous session we have seen the compilation array. How to see declare the compilation array means at the time of the compilation only that array size is fixed, array is allocated. But second way also we can create by using the malloc function, that array can be created. Array can be created at runtime also. How do we create the runtime means first we need to write one pointer and right hand side should be one malloc function. So size can be mentioned at the time of the runtime. So now we see the C supports two types of arrays. C supports two types of arrays. One is fixed length arrays. Fixed length arrays means the programmer write the size of an array which is a fixed. Second one is variable length array. The programmer does not know the array's length until runtime. Until runtime, this is a variable length array, means runtime memory allocation. The array can be allocated at runtime. Now we see just one simple here. For int count of 10 comma I count of 10 comma I, for I equal to 0 semicolon I less than 100 semicolon I plus plus. Okay. So what happens here? Garbage values can be stored into the array. Garbage values stored into the array, because up to 10 only we can access, but the size this loop will execute 100 times. So memory will be accessed that as garbage values. Next, if you use an invalid subscript in an expression, you will get unpredictable results. If you use an invalid subscript in an expression, you will get unpredictable results. Next. So this is the initialization of the 1D array. This is the initialization of the 1D array. General form is data type, array name, in the square brackets we write the size of an array equal to opening braces values list and closing braces semicolon. This is the initialization of the single dimensional array. Example you can see here, int scores of 5. Int scores of 5 equal to 60, 40, 90, 80, 60. These values are stored into squares of 0, squares of 1, squares of 2 and squares of 3 and squares of 4. Squares of 0, squares of 40, squares of 1 is 40, squares of 0 is 60, squares of 2 is 90, squares of 3 is 80, squares of 4 is 60. Okay. This is the initialization of an array. Here the just int scores of 5. Here the 5 is optional while we are initializing the array. While we are initializing the array, if you do not write the size also no problem. By default it takes size is 5. By default it takes size is 5. Here if you want to access the 60 value in this array, we have to write squares of 0. Okay. If you want to access 40, then we have to use squares of index of array, that is squares of 1. If you want to access 90, then we have to write the squares of 2. If you want to access 80, you have to write squares of 3. If you want to access 60, then you have to use squares of 4. In general, squares of 5, where I is a variable which varies from 0 to 4. So, array name itself is a address. Array name itself is a address, that is called first letter. Here just look here, squares of 60, 0 means the name of this base address is squares of squares. Okay. Next one is squares plus 1, next one is squares plus 2, next one is squares plus 3, next one is square plus 4. Okay. This is the first address is called, first element address is called base address. First element it's called base address. Okay. There are the difference between the pointers and arrays. Pointers and arrays, pointer is not a constant address, whereas the array is a constant address that cannot be changed. This is the difference between the array and pointer. Just array name itself is a base address. When an array is declared, the compiler must allocate a base address, okay, and a sufficient amount of storage to contain all the elements of the array. Okay. Whenever we are creating an array, means declared one array, the compiler allocates the base address. We do not allocate the address, it will be allocated by the compiler. First, array name itself is a base address. For example, the array name is A of 0 is the base address. A of 0 is the base address. Yeah, one important interview question, this is difference between pointer and array name. Difference between pointer and array name. A pointer variable is one that holds an address and can be changed. That address may be changed, which contains the address in the pointer to point to another object or another array or another structure or another variable of the pointer's type. But whereas the array name is base address of that array which cannot be changed, it means it is a constant. It is a pointer constant. Array is also called as the pointer constant. I repeat, an array is also called as the pointer constant. Pointer constant means that address cannot be modified, that address cannot be modified. That is the meaning of the pointer constant. Array is also called as the pointer constant. I repeat once again, what are the difference between the pointer and array? Okay. Where the first, a pointer variable is one that holds an address. Pointer variable which contains the address of a variable or a structure or a array, okay, and which points to another object also. We can reuse that pointer to another resource or another object, structure or array or variable. But whereas the array that cannot be reused, we cannot reuse, okay, because it is a pointer constant. It is a pointer constant. Just here carry A of 3. Here char A of 3, just I declared one character array. Here A is the array of type character. What is the size? 3, and each element occupies 1 byte of memory. So, total size of this array is 3 bytes. A of 0 is treated as the address, base address. Okay, that address may be 1000. This is my assumption. This is my assumption. This is my assumption. Actually, these addresses are represented in the form the hexadecimal form. I repeat, these addresses are represented hexadecimal form. Okay, that is 0x, some values will be there. Okay, who will assign this address? Who will assign this address? This is assigned by the system, but not the programmer. We can declare the variable, but we cannot assign the address. We can assign the values to the variable, but I cannot assign the addresses to the variables. I cannot initialize the addresses to the pointers. It is done by the system only. Here A of 0 is treated as base address. Base address means array at first location's address is called base address. Second address is 1001 because each element occupies only 1 byte of memory. So, after incremented 1, that is 1001. Next 1002, it is contiguous memory allocation. If int is stored in 4 bytes, okay, like this it will be stored. It will be stored like this: A of 0 equal to 7, A of 1 equal to 8, A of 2 equal to 11, A of 3 equal to 16, A of 4 equal to 23. 1, 2, 3, 4, 5. Total is size 5. Okay, because of the integer array, 5 into 2 means 10 bytes of memory is allocated. First address is 1000, next address is 4, next address is 8, next address is 12, next address is 16. Okay. In case of it is Linux operating system, these are the 0, 1, 2, 3, 4, these are the indexes of an array. Indexes of an array. A of 0 is the subscript, A of 1 is the subscript at 1, A of 2 is subscript at 2. Okay? Right. See here, because an array name A is a variable, okay. So, no need to write ampersand of A while we are initializing the pointer A equal to P, okay. A itself is a address. We do not write the ampersand here while we are initializing the pointers. So, if you want to add the entire array, then we write that ampersand operator. How do you pass 1D array to a function? How do you passing an 1D array to a functions? Okay. When an array is being passed its base address, means we send the address, base address, okay, without index is passed. There are we can pass in two ways: call by value or call by reference. Here we pass the array size and array address, base address. Here the int a square brackets is a pointer. We are allowed use of square brackets to remind us it as an array, address is being passed in. Yes, this is a function call. These are the syntax for the function call. This is the example for the function call. You can see here sum a comma n. What does it mean by a comma n? Here sum is a user defined function call. Okay, we are calling the sum function. We are calling the sum function here. Here a is a base address of that array. Base address of that array. Here n is a size of an array. Here n is a size of an array. Remember one thing, while we are calling the functions, while we are sending the array to a called function, we must pass the two parameters, actual parameters. First one is array name, second one is size of an array. Then only it is valid. If you do not pass the size of an array, if you are passing only single parameter, actual parameter, that is the name of an array, leads to error. Okay, it is 100% valid in Java, but not in C and C++. We have to pass two parameters. The first one is array name, second one is size of an array. Then only it is valid, but in Java no need to send the size. In Java no need to send the size. Simply we can pass an array. Simply we can pass an array in Java. So look here, sum v comma 100, v here, just look here, sum of v comma 100, here v is nothing but an array, comma 100 means size, 100 means size here, 100 means size here. Yes, look here, another example you can see here, that is in main function I am calling one function call. Okay. Second one is I am sending one pointer here. Second one is I am sending created one array. Here the second one is unsized array. Okay, there are three variables, three types we are writing the called functions. Next we go for the two-dimensional array. Say collection of one-dimensional array is called two-dimensional array, or definition, second definition also, collection of rows and columns are called two-dimensional array. It is a part of the multi-dimensional array. It is a part of the multi-dimensional array. Okay. There are two definitions we can find out. One is, say collection of the 1D array is called two-dimensional array. Collection of one-dimensional array is called two-dimensional array, or a array is a collection of rows and columns is called two-dimensional array. Yes. The number of bytes of memory needed to hold it. For example, here int d 10 20. Okay. Here the what is the size of an array d? 10 into 20. So each element, if it is case 4 bytes occupies. Okay. 10 into 20 into 4, that is 800 bytes will be occupied. The row and column, left index is treated as row. Okay. Left index means here, left index here. Okay. Int d of 10, okay, of 20. Here the d 10 is nothing but a left index. Okay. Left index is treated as row. Okay. Right index is treated as column. This means that right indexes changes faster than the left index when accessing the elements in an array, okay, in the order in which they are actually stored in memory. This is one example here. This is one example here. Just look here. 4 cross 3. 4 cross 3. Size CH of 0 0, CH of 0 1, CH of 0 2. Okay. Next CH of 0 2 means of size right side index. Okay. That is 2 because started with 0. Left index is and determines row. Okay. Right index determines column. I will write one simple program, then you can understand easily. Void main, I am initializing the array A of 3, A of 2 or 3, 3 cross 3 matrix I comma j. So, so I want to read the array, read 2D array. Printf enter 2D array. I want to read the 2D array now. Scanf for loop we must set the 2 for loops is demanded here. I equal to 0, I less than 3, semicolon, I plus plus, enter. For j equal to 0, j less than 3, semicolon, j plus plus. Okay, we need to close here. Scanf percentile d, only we write only 1 percentile d. Here how do we write? Ampersand A of I, A of j. If it is only single statement is there, so it is optional here. No need to write, for only for our understandable only we are writing. So, this is a reading the data from the keyboard, 2-dimensional array. So, you may get one doubt. So, array itself is a address, then why do we write the ampersand operator? No need to write ampersand operator, right? Then why do we write the ampersand operator? Means we are not accessing the A, we are accessing the subscript indexes. Okay, each index is treated as a variable. So, we are storing into the variable, that is ampersand is mandatory here. Ampersand is mandatory. We are not processing for the address A, we are processing the A of 0. Okay, that is ampersand is mandatory here. This is the reading the data from the keyboard. Hope you understood this one. Then how do we display an array? How do you display an array? Okay, printf for user understandability we are writing better understandability the array as follows, array as follows. I equal to 0, I less than 3 semicolon I plus plus. Next, for j equal to 0 semicolon j less than 3 semicolon j plus plus. So, here we write printf %d a of I. Here no need to write. So, for the next statement here I am writing printf next line \n. Okay. If you do not write the second printf here, it will be treated as a same number. So, I need to display a next line, or else at least you can write here, the tabular space also, no problem. This is the reading the data and printing the two-dimensional array. So, here we have to write j also, here we have to write ij. Okay. The first iteration means a of 0 0, second iteration means a of 0 1, third iteration means a of 0 2. Okay. Next iteration j becomes 4, j becomes 3, 3 less than 3 which becomes false, control comes out of the inner for loop, this inner for loop. So, again next control comes to here, printf next \t means tabular space is printed. Next iteration I plus plus, like this it will be executed. This is a two-dimensional array initialization. We can write in two ways here. Okay. To better understandability, we write something like this, right hand side. Okay. This is subaggregate grouping. Okay. This is not subaggregating grouping, directly we are writing. This is subaggregate grouping. Ten rows and 2 columns. So, here two-dimensional unsized array initialization, okay, but write subscript, we must write the column name, that is 2 here. Okay. If you do not write here also, no problem, first subscript, but here the size must be maintained in the second. How do we pass the two-dimensional array to the function? How do we pass two-dimensional array to a function? When a two-dimensional array is used as an argument to a function, only a pointer to the first element is actually passed. Okay. However, the parameter receiving a two-dimensional array must define at least the size of the rightmost dimension. Just look here. This is the syntax. Here we are writing the void function, defining the function int array subscript, means array square brackets next size. This is a reading, displaying, accessing the array, already seen. For two-dimensional array, we must write the two loops. Two nested loops are demanded for the two-dimensional array, inner for loop and outer for loop. Okay. One-dimensional array is only single loop is enough. Two-dimensional arrays, 2 loops are required. If the dimensions are increased, loops also will be increased. I repeat, If the dimensions are increased, loops also will be increased. Three dimensional array means we need to write the 3 loops, nested, nested, nested. This is the 3-dimensional array syntax. Okay, you don't worry about this 3-dimensional array, because we don't know. A single dimensional array is very difficult now we are facing. If it is 3-dimensional array means we cannot understand. So you don't worry about, only you just concentrate on 1-dimensional array and 2-dimensional array as of now. Just you can see here. So now I will write one program. How do we copy from one array to another array? Okay, how do we copy one array to another array? Copying one array to another array. One array to another array. We are writing one program here. Include stdio.h hash include kunyo.h void main into a of 4 comma b of 4. These are the 2 arrays. I want to copy from A to B now. Okay, we also declare the I. Next, printf enter arrays, enter elements into A, elements into array A. Next, for loop we must write, right, I equal to 0, I already declared, semicolon, I is less than 3, 4, because size is 4, I plus plus. Next, first we are reading the value, that is scanf %d within double quotes ampersand of A of I, A of I, A of I. So this is the reading an array. Once we read the array into the A, elements into the A, now what my objective is, I need to copy into B. I am not at all reading the values into B, only I want to copy from A to B. Okay, how do we write? We already stored into variables into A. Now I want to copy the same logic, same loops I am copying, simple logic. It's very simple logic. Okay, where we have to store P of I, right, equal to A of I, that's it. This is the logic from copying from one array to copying from one array to array B, array B. Okay, for where is the source here? A is the source array, A is the source array, B is the destination array here. Okay, always left hand side must be variables only. Okay, right hand side may be value. Here A of 1 means A of I, A of 0 means the value at address, the value at subscript I equal to 0, index 0. Okay, it may be anything that is stored into b of 0. Okay. Next iteration b of 1, next iteration b of 2, next iteration b of 3, next iteration control comes next iteration b of 3 or a of 3, it control comes out of the for loop because size is 4 only. This is the simple logic from one copying from one array into another array. So, we can display now, display array B. Printf %LD B of I. That is it. This is the displaying an array. To display an array, we know that logic, but only thing is this is the logic to copy from one array into another array. Copying from one array into another array. How do you copy the two-dimensional array? Same. It's very simple. Instead of b of I, you have to write b of ij equal to a of ij. That's it. Very simple. Copying from one array into another two-dimensional array is the same process, but only thing is you have to write the, instead of b of I equal to a of j, you have to write the b of ij equal to a of ij. That's it. That's it. So, we can copy from one two-dimensional array into another two-dimensional array. This is the copying arrays. Next, we do some programs on sorting, now we do some programs on sorting. So, how do we write the sorting an array? How do we write the sorting an array? Just copy this one, just you can copy this one. First read an array, okay. Once you read an array, or you can initialize an array, what should we do? Next, swapping logic must be written. Okay. Swapping logic must be, if you know the swapping logic, then only you can write the array. Okay. Before going to this bubble sort, I will explain about the what is sorting here. What is sorting here? What is sorting? Swapping logic. Include stdio.h hash include void main swap int. This is a function prototype, int a comma b int a comma b semicolon. So, while we are swapping, I must write the pointers here. Next, a equal to b equal to 3. So, I need to interchange these two values. Printf before swapping, printf %LD a equal to \n, next b equal to \t %LD \n comma A comma B. So, this is the values before swapping. Next, swap. Now, we are doing the swap function here. I am sending called as call by reference. Next, printf %d A equal to %d \n, next B equal to \d %n A comma B semicolon. So, now I have to define the swap function. Void swap, this is the definition of the swap function. Swap function definition. Void swap int star x comma int star y. So, to receive the addresses, it must be pointers as a formal parameters. So, we are sending the addresses of the actual parameters. So, formal parameters must be pointers. What is actual parameters and formal parameters means? When you are sending the function call, when we are sending the variables or addresses or values from the function call, then it is called actual parameters to the called function. I repeat, actual parameters means whenever we are in the function call, whatever we are sending the arguments or variables or values, okay, those are called actual parameters. What is formal parameter? Formal parameters means the variables list inside the function is called formal parameters. Okay, whatever the receiving the variables are called formal parameters. Actual parameters may be values or variables, but whereas in the formal parameters must be a variables only. I cannot write the constants there. Okay, come here. Next, int temp ampersand of x. I am storing the a value into temp. Next, ampersand b equal to ampersand x equal to ampersand b. The value ampersand phi, the value of b value is storing into a. Next, ampersand of phi equal to temp. Okay, this is a simple logic. This is the logic we are going to implement in sort function also, bubble sort also. This is the logic we are going to implement in bubble sort. Okay. If you understand this swapping logic, it becomes very simple to write the bubble sort. So, first what we are sending here 2, 3 are the variables. Okay. 2 is stored into A, whereas 3 is stored into B. Okay. Before swapping, A equal to 2, B equal to 3. Okay. Next, I am calling the swapping function. This is a swap function call. Swap function call, it is a user defined, means it is my swap function. I have written, it is mine only. So, here I am sending the address of A. Here I am sending the address of A, that is 2 address, it may be 1000. Next, address of B means value variable of address of B, that is 2000. Okay. It may be 2000, this is my assumption. Okay. These addresses are copied to where? Int pointer x, assigned to pointer x and y. So, whatever we changes the modification that is reflected to the actual variables. Because we are sending the values, not values, we are sending the addresses to the called function. This is the called function. Here the swap is a called function. Swap is the called function. So, this next, after executing this fully swap function, now the control comes to the calling function printf. A is modified values, that is A equal to 3, B equal to 2, we will get. Here the output is whatever the output, what is the output we get here, output before swapping A equal to 2, B equal to 3. Okay. After swapping A equal to 3, B equal to 2. This is what we are expected output. Now we will see the what is bubble sort. Okay. First, just look here. First we are initializing an array, or you can read the values from the keyboard. A of 6, a size is 6 here, 5, 8, 2, 9, 1, or I am storing into an array, the name is A. So, A of 0 is 5, A of 1 is 8, A of 2 is 2, A of 3 is 9, A of 4 is 1. Okay. This is the memory representation. Next, I think you understood this first statement. Okay. Next, we go for the next statement, that is int I, j, temp. Okay. These three variables are created somewhere in the memory. With garbage address. Next, come to the loop. Now the control comes to the for loop. For I equal to 0, I less than or equal to 5 minus 1, I plus plus. Means now the I value is 0. Now I value is 0. Okay. I 0 is less than or equal to 4. 5 minus 1 is 4, right? 0 is less than or equal to 4. The condition becomes true here. So, whenever the condition becomes true, control enters the body of the for loop. Now, the control enters the body of the for loop. Okay. Next, inner for loop. Now, the control comes to the inner for loop. J equal to I plus 1, semicolon, j less than 5, semicolon, j plus plus. J equal to I plus 1. What is the value of I? Here the value of I is 0. You can see here the value of I is 0. Okay. Now, the j value is I plus 1. I means 0 plus 1. So, j value is 1. So, the j value is 1. So, j value is here 1. It indicates the second subscript, that is 1's index. Hope you understood here. Next, j less than 5. Next, j less than 5, j means what? 1 here, 1 less than 5 which is true. Whenever the inner for loop becomes true, control enters the body of the inner for loop. What is the body here? That is if condition. If A of I is greater than A of j. A of I means what here? I means 0, A of 0. A of j means what here? 1. Okay. A of 0 is greater than A of 1. A of 0 means what here? 5 is greater than 8. 5 is greater than 8. So, I am comparing the first element to the next element. 5 is greater than 8, okay, which is false. Which is false. A of 0 is greater than A of 1, which is false, means 5 is greater than 8, which is false. So, do not swap the values. Do not swap the values. We are writing after, if the if condition becomes true, it has to be swapped. Swap. So, if it is false, do not swap. Do not swap. So, we are not swapping. Again control go back to the inner for loop, that is J plus plus. J plus plus. Okay. Now, the J plus plus, J is right now that is 1, that is J plus plus means 2. Now, the J value becomes 2. J value becomes 2. Okay. So, whenever the J value becomes 2, now I am comparing 2 less than 5, 2 less than 5, 2 less than 5, which is true, condition becomes true. So, now the control enters the body of the if condition. Body of the if condition, that is A of I is greater than A of j. What is the I value? That is 0. What is the j value here? 2. What is the j value? That is 2. So, A of I is greater than A of j means A of I means A of I, that is 5, greater than A of j. A of j means 2, that is 2. 5 is greater than 2. So, it is true. Whenever the if condition becomes true, swap the values. Swap the values, that is 5 and 2 are interchanges. 5 and 2 are interchanges here. Okay. Swapping logic applied here. Swapping logic is applied. So, now we are swapping here. 5 and 2 are interchanges, that is swaps. Swapped A of I and A of j. Just look here, in the first element it was 5, okay, that is A of j is 2. So, after swapping A of I becomes 2 and A of j becomes 5. Swapped A of I and A of j. Swapped A of I and A of j, right. Next, j plus next iteration, after execution of the if statement, if body, now control goes back to the inner for loop, that is j plus plus. Now, the j value is 3. After incrementation of the j plus plus, j value is 3. So, 3 is less than or equal to 5. 3 less than 5, which is true. 3 less than 5, which is true. So, whenever the condition becomes true, now the control enters the body of the inner for loop. Body of the inner for loop. So, A of I is greater than A of j. A of I is greater than A of j. Okay. What is the A of I here? A of I is 0. A of I is 0. A of 0 is equal to is greater than A of j. A of j means A of j, that is 3, subscript 3, that is 9. Okay. 2 is greater than 9. 2 is greater than 9, which is false. 2 is greater than 9, which is false. Whenever the condition becomes false, do not swap. Okay. If it is true only, we need to swap. So, that is the reason. So, it is not swapped. It is now it became false. Now, it became false. So, do not swap. Again, next iteration of the inner for loop, j plus plus. J plus plus, now the j value is 4. Now, the j value is 4. Okay. 4 less than 5, 4 less than 5, which is true, condition is true. Whenever the condition is true, control enters the body of the inner for loop. body of the inner for loop, that is if A of I is greater than A of j, if A of I is greater than A of j, A of I means what? I equal to 0, whereas j equal to 4. I equal to 0 means that is 2, A of j means A of 4 is 1. Okay? 2 is greater than 1, which is true, which is true. 2 is greater than 1, which is true. So, whenever the condition becomes, this if condition becomes true, control enters the body of the if condition. That means swap those values, means 2 and 1 are exchanged, interchanged, swapped. That is what we are doing here. Temp equal to A of I, that is 2, 2 is stored in the temp. Next A of I equal to A of j means I am swapping A of j is 1, A of j is 1 is stored into A of 1. Okay. Next A of 0 equal to 1, just look here, A of 0 equal to 1. Next A of j equal to temp, temp value is 2, 2 is stored into A of j, that is A of 4. Okay. Next this is fully executed. Now the control go back to the inner for loop. J plus plus, j is incremented by 1, j is incremented by 1 means what? J equal to 5, j equal to 5, 5 less than 5, which is false, which is false. Whenever the inner for loop becomes false, control goes to the outer for loop, that is I equal to 0, initially I equal to 0, now I value becomes 1 now, I plus plus means I equal to 1, just I plus plus, now I equal to 1, just you can see here I equal to 1, arrow mark. So 1 less than or equal to 4, which is true, 1 less than or equal to 4, which is true. Okay. Whenever the outer for loop is true, outer for loop is true, now the control enters the body of the inner for loop, body of the inner for loop, body of the inner for loop. Okay. Now the control enters the body of the inner for loop. Now the j equal to j plus 1 semicolon, j less than 5 semicolon, j plus plus. So j equal to I plus 1. What is the I value now? That is 1. 1 plus 1 means j equal to 2 now. J equal to 2 now. Okay. 2 less than 5, which is true. 2 less than 5, which is true. Now you can see here diagrammatic representation. Okay. So next, if the condition is true, now the control enters the body of the inner for loop. If A of I is greater than A of j, A of I means what here? That is 8. A of I is 8, is greater than A of j. A of j means what? That is 5. So 8 is greater than 5, which is true. So 8 is greater than 5, which is true. Now the control enters the body of the if condition, means we need to swap this one. Those are swapped. Okay. We see the swapping logic here. First, temp equal to A of I. A of I equal to what? 8. Next, A of I equal to A of j. A of j means what here? That is 5. 5 is stored into A of 1. See here A of 1. 5 is stored. Next, A of j equal to temp. Temp is what? 8. 8 is stored into A of j. Right. Next iteration j plus plus. Next iteration j plus plus. J is incremented by 1. J is incremented by 1 means what here? 3. 3 less than 5, which is true. Next, if condition. Okay. A of I is greater than A of j. A of I means what here? 5 is greater than A of j, which is false. Next iteration j plus plus, that is now j value is 4. 4 less than 5, 4 less than 5, which is true. Next, if condition will be control comes to if condition. A of I is greater than A of j. So, phi is greater than 2, which is true. So, now control enters the body of the if condition. Now, the swap the values. Swap the values of the A of I and A of j. So, phi is replaced with 2 and 2 is replaced with phi, that is interchanging the values. Okay. Next iteration j plus plus. Next iteration j plus plus. J is incremented by 1. J is incremented by 1, that is phi. Phi less than phi, which is false. Phi less than phi, which is false, control comes out of the inner for loop. So, control comes out of the inner for loop. So, phi less than phi, which is false. Next, control go back to the outer for loop. Control go back to the outer for loop. So, actually I equal to 1 now. So, 1 is incremented by 1, that is 2. 2 less than or equal to 4, which is true. Okay. Now, control enters the body of the inner for loop. Now, the j equal to I plus 1 means 2 plus 1, that is 3. 3 is stored into j. 3 is stored into j. J less than means 3 less than 5, which is true. 3 less than 5, which is true. Control enters the body of the inner for loop. Inner for loop, that is if A of I is greater than A of j. A of I is greater than A of j means A of I means what? A of I equal to 8 is greater than A of j means 9. 8 is greater than 9, which is false. Which is false. So, do not swap. So, do not swap the values. Again j plus plus. Next iteration j plus plus. J is incremented by 1, that is 4. Okay. 4 less than 5. 4 less than 5, which is true. 4 less than 5, which is true. Whenever the condition becomes true, control enters the body of the inner for loop. Control enters the body of the inner for loop. Now, the control comes to the if condition. Just check this diagram. If A of I is greater than A of j. If A of I is greater than A of j, okay, here A of I means what? 8 is greater than 5, which is true. So, interchange those values, means swap the values. Swap the values. Next j plus plus. Now, the j value is 5. 5 less than 5, which is false. 5 less than 5, which is false, control comes out of the inner for loop. Again control go back to the outer for loop. Outer for loop. So, I plus plus. I plus plus. I is incremented by 1 now. I is incremented by 1, that is 3. 3 less than or equal to 4, which is true. 3 less than or equal to 4, which is true. Control enters the body of the inner for loop. Now, see the diagram here. Next, outer for loop. J equal to I plus 1, 3 plus 1, that is 4. 4 less than 5, which is true. Okay. Next, if condition. If A of I is greater than A of j, means 9 is greater than 8. 9 is greater than 8, which is true. So, whenever the condition is true, swap the values. Here the swapping the values. 9 and 8 are the swapped, means 9 is replaced with 8 and whereas 8 is replaced with 9. Swapped successfully here. Next iteration j plus plus. J is incremented by 1, that is 4 now. 4 less than 5, which is true. J 5 less than 5, which is false. Again control comes out of the inner for loop. Inner for loop. Next control goes to the outer for loop I plus plus. I plus plus. So, 4 less than or equal to 4, which is true. So, now j value is, now the j value is 5. Okay. 5 less than 5, which is false. Again control comes out of the inner for loop. Okay. Next outer for means outer, control goes to the outer for loop, that is I plus plus. I equal to 5 now. 5 less than or equal to 4, which is false, control comes out of the outer for loop. So, this is a sorted array as follows. If you know the swapping logic, bubble sort becomes very simple. This is the bubble sort logic. First, we need to initialize the values or read the values into the array. Okay. Next, compare each element into the next element, If the first two are true, next swap those values. This is the logic. It's very simple, and if you have any doubts, you can write the mails. If you write the mails, okay, that is rajendra.apssdc@gmail.com. rajendra.apssdc@gmail.com. You can post your doubts and questions. You can ask me on technical. Okay, I will respond to you. Thank you all the best.